In the frigid emptiness over Antarctica, some 430,000 years ago, a fireball tore through the sky. It was not a typical meteor. It never reached the ground to leave a crater as a smoking scar upon the Earth. Instead, this extraterrestrial body exploded in the atmosphere with such magnitude that molten debris rained down onto the ice sheet below, embedding itself as microscopic spherules that would remain locked in time. This was the Walnumfjellet meteoritic event, an impact so powerful that its airborne debris has only recently been recovered and dated. And yet, thousands of miles to the north in a limestone cave in what is now Spain, a different drama was unfolding, one buried deep in the earth, among the bones of our ancient ancestors. Geologists know this event as Termination 5, the sudden end of a glaciation and the beginning of a warm interglacial. The Cima de los Huesos cave site in the Atapuerca Mountains contains the remains of at least 28 individuals, early Neanderthals or close relatives, dating precisely to this same moment in deep time. Among them lies one individual whose fractured skull tells a sinister tale. Was he the victim of the world's oldest murder? Or could his death have been a direct consequence of the fallout from the meteor that lit the skies of Antarctica with fire? To unravel this mystery, we must step back into the mid-Pleistocene, a time of fierce glacial cycles, soaring sea levels, and a hominin population just beginning to acquire the cognitive, social and physical traits that would one day give rise to modern humanity. The Walnumfjellet meteoritic event was first described by a 2021 study which detailed the discovery of 17 tiny spherules embedded in the Rondon Mountains of East Antarctica. These spherules, composed of nickel-rich impact-generated glass, bear unmistakable signs of a meteoritic origin, including oxygen isotope ratios that prove they formed during explosive contact with ice, not rock. The team determined that a chondritic asteroid at least 100 meters wide entered Earth's atmosphere and exploded with enough energy to liquefy and disperse rock and metal over vast distances. Unlike the 1908 Tunguska event, this cosmic detonation was not just a fireball, but an intermediate event, more powerful than an airburst, yet not quite a full terrestrial impact. Its effects would have sent pressure waves across the stratosphere, incinerated vast ice fields, and possibly vaporized local ecosystems. The energy involved was likely greater than 100 megatons, orders of magnitude above nuclear weapon detonations. While centered on Antarctica, the stratospheric dispersal of aerosols, gases and debris may have caused cascading atmospheric consequences, especially as it coincided with a tipping point in global climate. As seen in the first chart, the 400,000-year event, known as Marine Isotope Stage 11, was marked by an enormous spike in sea level and CO2 concentration. From ice core data, we know that CO2 rose above 280 ppm at this time, unusually high for the Pleistocene, and remained elevated for an extended interglacial phase. This warming, which began just after the estimated timing of the meteor event, may not be coincidental. Massive stratospheric injection of dust, carbon monoxide and vaporized ice can temporarily cool Earth's surface. But after the initial albedo spike, the long-term effect of such impacts often leads to warming. Melting polar ice from the heat pulse, combined with oceanic carbon release, can result in sustained interglacial conditions. In the case of Marine Isotope Stage 11, sea levels rose by up to 20 meters higher than present day, as reflected in the geological sea level reconstructions. This was one of the warmest and longest interglacials of the entire Quaternary. Did the 430,000-year-old impact act as a trigger, nudging Earth out of a glacial cycle and into a prolonged interglacial? The correlation is provocative. The timing aligns almost too perfectly with the warming phase that followed. At the time of the impact, much of northern Europe was locked in glacial conditions, but as the climate warmed in the aftermath, the landscape underwent transformation. Ice sheets retreated, river valleys surged with meltwater, and coastlines shifted. Tsunami events may have occurred, triggered by polar collapse or even by the shock waves of the impact itself. In fact, such waves could have reached distant continents. In Western Europe, The warming transformed formerly barren glacial zones into lush, temperate forests. These rapid environmental changes would have been dramatic and dangerous for any hominins struggling to survive. Regions that were safe one year might become flooded the next. Newly opened land may have been destabilized by permafrost melt or landslides. Such times were ones of chaos and desperation. It is within this context that the Cima de los Huesos population found themselves perhaps fleeing rising waters, violent storms, or food shortages. Could this sudden environmental stress have led them to retreat into caves for refuge? Could tribal violence have erupted over scarce resources in a newly volatile world? Deep in the karst systems of Atapuerca lies a shaft known as the Cima de los Huesos, the Pit of Bones. Accessible only via a steep vertical drop, it contains a remarkable collection of human fossils, 7,000 bones from nearly 30 individuals, all dating to around 430,000 years ago. These bones belong to hominins, with a mixture of archaic traits and emerging Neanderthal features. Their morphology is robust, with thick brow ridges projecting mid-faces and large brains averaging around 1,200 cubic centimeters, signs of a population in transition. One skull, known as Cranium 17, tells a tale of violence. It exhibits two closely spaced, nearly identical fractures on the forehead with no signs of healing, meaning the individual died shortly after receiving the blows. The shape and location suggest a deliberate attack with a blunt object, likely by another human. This makes it the oldest known case of homicide in the fossil record. But what was the motive? While interpersonal violence is not uncommon in human prehistory, the timing of this death, 430,000 years ago, precisely when the Meteor event occurred and the climate began to shift, raises unsettling possibilities. Could the victim have been struck down amid a chaotic retreat into the cave? Could the violence have stemmed from disputes over dwindling shelter or food in a landscape suddenly transformed by flood and fire? Even more speculative, could the injury have come not from a club, but from debris? Some researchers have pondered whether falling ejecta, pressure waves, or tectonic disturbances from distant impacts could lead to trauma. While this is unlikely in this case, the symmetry and angle of the injuries strongly suggest interpersonal violence. It underscores the volatility of the world these early humans inhabited. A sudden environmental crisis set in motion by a meteor could easily provoke aggression, fear, and violence. Why were so many individuals found in a single pit? One hypothesis is deliberate burial or body disposal, a practice far older than previously thought. Another is that the bodies were simply discarded there after death elsewhere. But the third, and perhaps most haunting possibility, is that these people died there together, trapped in a place they believed would offer safety. If the earth trembled and skies darkened, if waters surged across valleys and food vanished from the forests, these early Neanderthals may have descended into the caves to wait out the storm, and they may never have emerged. It's also possible that Cima de los Huesos became a kind of mass grave over time, used ritually or socially to dispose of the dead, a tradition that could have its origins in a cataclysmic event that demanded new forms of remembrance. The timing of this meteor event, and the emergence of Neanderthal traits in the Cima population, is striking. It is as though, in the crucible of global warming, ecological transformation, and social stress, a new lineage of humans was forged. Natural selection often moves fastest in periods of rapid change. The environmental shockwaves following the Antarctic impact could have contributed to an evolutionary bottleneck or acceleration. Increased cognitive planning, group coordination, and the use of symbolic spaces like burial sites may have emerged as adaptations to a newly dangerous and dynamic world. The violence evident in the Cima skull may not just be a random act of aggression. It may represent the earliest sign of complex social tension, hierarchy, conflict, perhaps even ritual. The meteor did not kill the Cima de los Huesos people, but it may have reshaped the Earth just enough to transform their world, and ours. The rain of metal that fell on Antarctica 430,000 years ago has long since vanished beneath layers of ice, but its effects, faint and lingering, may echo in the fossil record of distant continents. The warming that followed ushered in a long interglacial, raising sea levels, transforming habitats and spurring migrations. It may have been one of the catalysts that split ancient populations into distinct lineages, Neanderthals in the west, Denisovans in the east, and eventually Homo sapiens in Africa. In the dark pit at Atapuerca, a story remains half-buried, a skull with 2 fractures, a climate in flux, a sky once lit with fire. The oldest murder may not have been just a crime, it may have been a message from the heavens echoing through the bones of our ancestors. Thanks for watching, and please subscribe and watch our other videos.